for the presentation is what I would call our construction technology. The tools that we use to help us work smarter and more efficiently to perform our primary function, which is to build buildings. We want to give you some examples of how we have applied the technology to the benefit of our clients, our trade partners, our design partners, and our staff, and then give you a chance at the end to ask questions. Hope you were present earlier in this week when Tick and Baker revealed Clancy and Thay's new mission statement. Each of these 4 pillars is applicable to today's topic: safety, stewardship, passion, collaboration. But I've asked our presenters to highlight 1 or 2 examples in their presentation, so be on the lookout for one of these icons in the lower right corner of a slide. While we can brag about our cool cutting-edge technology, it's really the dedication and the talent of our people behind our technology that is the most important. It's always about the people. Our drone program is growing. Our pilots are not only required to pass an exam for FAA certification, but they receive additional training and certification from industry experts, all in addition to their own full-time duties. I want to welcome our newest pilot as of November of this year, Garrett Lewis, in the Charlotte office, and he joins Matt Racher, who serves now as our drone coordinator for the whole program, Kyle, Zach Emerson, and with Lee in Newport News, and then of course Garrett in Charlotte. We want to also welcome Matt Racher to our Raleigh VDC staff. He joined this past August, and he joins Kyle Schneider and Laura Kaiser here in Raleigh. And I want to remind you that these 3 are also corporate resources. This year, we provided assistance in job pursuits for the Wilmington, Charlotte, and Orlando offices. And the Orlando team feels our technology presentation distinguished us from a formidable competitor and contributed to the win of that project, the Villages K-8 project. We're going to be backing them up, their whole team up, by managing the BIM coordination process once construction kicks off. In the Newport News, on VDC, we've also got Todd Rasmussen, who also serves as a project manager, Zach Emerson and Cassie Weidinger. They are here and will be presenting some of their work today also. I want to thank each of our VDC staff for what they do at Clancy and Thay's and for taking time to put this presentation together for all of us. This is their presentation. They did it. In October of this year, 12 Clancy and Thay's employees participated in the CM BIM classes for certification. BIM is all about collaboration and teamwork. In fact, some industry leaders have said that BIM is 10% technology and 90% sociology. These folks attended 32 hours of classes to learn best practices for setting up a coordination team so that it is collaborative and gets results. As you can see, all of our VDC staff participated, as well as 6 project managers and APMs representing 4 divisions. Lane Gorell, an APM in Raleigh, has taken and passed the exam, and he can now use the CM BIM certification in his signature. I'm going to go ahead and ask Cassie Weidinger to give you just a little information about her experience in that class.
Thanks, Harry. The CM BIM classes explain the fundamental terminologies and project setup needed to execute a VDC project successfully. The process really does start in estimating when we start asking questions up front about file formats from designers and what the expectations are from a modeling standpoint for our subcontractors. Simply put, there are levels of spatial coordination such as 2D, which uses programs like CAD. We have 3D, which uses programs like Revit and Navisworks. We have that in-house. The next level is 4D, using a program called Synchro, and it's the process of connecting a 3D model to a schedule. 5D is the other layer. It adds quantities to a model and a schedule. One of the more important terms is level of development for a 3D model, and then those can vary from 100, 200, 300, 350, and 400. All these basic terms will be discussed in a BIM execution plan when we're setting up a project, but for more information, you can visit the Clancy and Thay's employee portal for a guide in implementing BIM into your project.
Thanks, Cassie.
Mm-hmm.
And Matt, if you can put the screen back, we've lost the actual projection screen. That happened the other day in the project. We're not seeing your share screen anymore.
Oh,
it's
okay.
because someone focused on her video, and that pops her face up in the middle of the screen.
Okay. So on my end, I just need to say present again.
No, whoever focused on her video needs to click her face and unfocus.
There we go.
Now
We're back.
you all can see this again. Great.
Yes. All right. This is a slide that pops up a lot when we are presenting to prospective clients. We tell them that most of these tools are going to be used on their project at some point, and it's no coincidence that of the 17 major platforms used at Clancy and Thais, 11 are primarily involving virtual design and construction. We're going to showcase a few of these today, and we're going to put extra emphasis on OpenSpace, which is our new photo documentation software. It's now available to every project with no direct charge to that project. And I'll be sending out some information about that in the future about how that works. But we're going to talk about that and show you that today. One last thing before we move to what you all really came here to see, I want to introduce this new concept that's been emerging not just in construction but in all industries. And it's called the Common Data Environment. The diagram on the left illustrates a traditional workflow. We've got multiple copies of the same file that's being transferred directly between each project participant. That's architect and contractor, owner, subcontractor. Lots of files floating in the cyber world. Multiple copies of the same file transferred directly between each project participant via email or file sharing platforms. And this creates a lot of redundant data that's stored on servers, local computers, and transferred back and forth. This can result in team members using outdated information, which we all know can be a disaster. So the diagram on the right illustrates a better way for doing this using a common data environment. The concept is that there's only one copy of the document stored in one place, accessible by everyone. This is the same concept, next slide, behind our BIM 360 initiative. It's built on top of a document management module that serves as this common data environment throughout the project. Laura's going to give an example in a minute of a few projects that we are actually sharing, where we are actually sharing the architect's model. That's not a copy. We are in their actual live model file in this BIM 360 environment. Other modules tap into this environment, things like Assemble software, which we have been using for quantity takeoff. Our new building connected software taps into the same environment for bid management. The new BIM 360 project module, the field management module for issues, checklists, daily logs, and finally project closeout. So now I've set the groundwork, and I'm going to turn this over to our VDC team to look at some real life examples, and I'm going to hand it off to Kyle.
All right, thanks, Harry. So before we jump into some of those projects, I wanted to kind of refine that technology talk and really speak to a few softwares here that I think really summarize our past year and give a good direction of where we're going. So I'm quickly going to just touch on them and then we can dive into each one. So the first one Harry mentioned, Autodesk Bim 360. This is really taking over, our project management from a document standpoint of our projects, and is that common data environment. Next is our drone photogrammetry software, which you've heard quite a bit about in the past, and it's really like a continued, just a workflow that it's just been common practice. This next new one, OpenSpaces, we're going to touch on, is now taking that photo documentation, but to the ground and how we're actually documenting our sites. And then lastly, Revisto, it really just building upon those softwares you've heard in the past, Navisworks and Revit. This is another additional tool that allows us to analyze our models, really utilizing those first three I touched on, bringing in the project documents and the drone data. So with that, we're going to speak a little bit about each one of these, and then we'll jump into some case studies. So Matt, if you want to go to the next slide.
Sure, thanks, Kyle. So as you heard Harry and Kyle discuss with BIM 360, BIM 360 Next Gen is going to be used on every new project that we have. And it's the document management module that really underpins everything within Clancy and Thais. So right now, using BIM 360 Design, some of our projects are using BIM 360 Design to collaborate with design teams. And then also want to address that there is a Autodesk desktop connector feature that makes it simple to integrate your BIM 360 project files with the rest of the files already existing on your computer. And you can even pick a specific project and pin it to your folders for quick access. So It's a really powerful software that we're very excited about and looking to the future, how it's going to help us achieve everything that we need within our projects. The next technology item I want to discuss is we are in the process of testing some new drone mapping softwares as well as drone fleet management softwares. So Clancy and Days currently uses a platform called SiteScan, but over the course of the past few months, we have tested 2 other big players in that field, those being Pix4D and Drone Deploy. And through this testing, we're ensuring that Clancy and Days is keeping up with the latest and greatest technology. You can see in one of the screenshots here, we have a recent capture from just November 20th of one of our projects. Got a crosshatch capture, so it comes in 3D. And also I want to address, we are trying to use this fleet management software for safety, in that we're going to require all pilots to fill out a pre-flight checklist before each and every flight and make sure that we're doing everything that we can to mitigate any dangers while using this great, exciting software.
All right, thanks, Matt. And then, not that we're going to cover the drone software too much, but for some new people on the call, just a kind of a little backstory. Really, the first project that we implemented this on was the Peace project a few years ago. And other than just getting some progress photos, it really found some value in, basically monitoring some of our PT slabs. So in this next slide, we kind of developed a workflow on this project of getting some overhead images, overlaying our drawings, and verifying sleeves that we're penetrating through there. And so this next slide is really just kind of like encapsulate where we are today, and really just continued success since that initial project. So me personally, I've done this on now 6 projects, over 40 pour overlays. We've identified really countless of those same issues, some missing sleeves, staying on top of our subs. And one interesting point is on that Peace project, we actually pointed out a few things that the concrete subcontractor missed, and they actually took it to heart after that, and they got one of their own employees licensed with drones, and they've been flying it out at our 301 job. So now we have some subs actually taking on some of this role in their work themselves. And upcoming in 2021, we have a few projects that are already going to come down the pipeline, and this is just going to be standard operating procedure on those projects. So with that, we can now jump over to open space, which I'm going to talk a little bit more on. Just high level, this is really using 360 cameras that turn our job sites into like a Google Street View, where you can freely walk throughout the job wherever we perform captures. So starting over there on the left-hand side of the screen, we have a 360 camera, which can mount to a number of different things, but there you see Fabian's walking, I think that's Briar Creek, but he has it mounted on his hard hat. That syncs to a device, an iPad, an iPhone, which has the open space software on it. You pin it to a floor plan, and you essentially just walk capturing a video. This video uploads, and they basically extract all the frames into this virtual world that you can walk. So if you want to go to the next slide, Matt, and I'll kind of talk over while this goes. So on the top right, you'll see how this works over here at the Smoky Hollow job. So basically, we can walk the job site, and these photos, basically all you do is pin where you start the walk, and that's it in the app. And then basically it extracts and overlays on the floor plan by itself, which is actually, it makes it very efficient to do these captures. And then what I'm showing here on the right is now we can also bring in some of our, VDC model data, and they can actually align this to those captures. So we can look at the side-by-side in real time. Not only are we doing the captures one time, but we can walk the site multiple times. So if you look at that image just down below of that split screen, we can see different times of construction side by side. And then right below there, you see all the levels. So it's one software environment where we're capturing multiple levels, multiple dates, as many times as we want, and the flexibility to move throughout it. There's a lot in there. So, I can't explain everything here in this one shot, but I think that gives you a good overview. And then the next slide, I have a few other points we're going to touch on here. So another cool feature in this is you can take what's called field notes, or you can take photo. You can see there on the iPad, you can take a photo as you're performing the walk. And the really slick thing about it is that it knows where along the walk you took that photo. So it basically places this photo and note directly on the floor plan, which you kind of see there on like the bottom right of the screen. You see all those field notes. And with this, we can make comments. It actually integrates back to BIM 360. So performing some of these walks, we can then start pushing some issues back that way. There's a number of different workflows we're kind of evaluating and looking where the direction it heads in. But it's an all-encompassing.
Yeah, we got that other one stuck out for you.
All right. And then I think, is this, Matt, do I have one more slide?
Yes,
yeah.
one more slide.
So now this is kind of like, so far in our use of it, I've found a few different areas that we've really generated a lot of value in this. And just starting in the top left corner, it's really just documenting an existing site. This is out at our Seaboard Station project, and we had a bunch of the utilities marked out in the street, and we wanted to document that, before it gets washed away. So we went out there and just did an open space walk, and now anyone can just re-walk that path and, look at everything that we captured there. It's great for renovation work. Then in the top right, it's really just monitoring the construction progress. I mean, that's really the main, the meat of the software. And there's a lot of different avenues you could go within the construction progress. And then the bottom left, that's now where we're starting to bring in our BIM data, and we can kind of do this side by side and bring the models to the field and kind of check what we've coordinated while it's going on. That's always an ongoing process. And then the last one, the bottom right, we actually just did this yesterday for the office building, is that maybe more of like a marketing or like a, finished completed building. We can now do some basically virtual walks of a completed space, and we can kind of walk people through that space. We could share that space with clients, people internal. After this call, Baker wants me to share a little bit of our office building with our team here so they can kind of get a sneak peek. But so far, this is just all we've found, and there's basically many different directions it can go in. It's just us developing it. So with that, I'll let Laura say a word here on Revisto.
Sure. So I think you've seen, like, from what Kyle showed, we're always looking at ways on, and related to what Harry talked to about too, about bringing all this data into one spot. Revisto is one platform that our VDC team has been using to kind of get all this information in. Some advantages are we can really easily overlay 2D drawings on top of the model. We can pull in photos and 360 photos kind of as we identify issues within the project and keep it all in one spot. We can use it as part of just our typical model coordination. We can also bring in drone data. So in this next video here, we're kind of looking at how all these different things can be brought together. We've got a 2D drawing from the architectural set. Because of how these drawings are exported, it knows where it goes in model space. We don't have to do any alignment. So we can come in here, we can get a general idea of space in that overall building section, but then we can really drill down here and look at some details and think about things that might not be modeled but show up in the drawings. We can overlay, obviously, plans on top of the model too. And here we're also looking at drone data. So we've got the model with drone data on top, and then a foundation plan. So we can use this as part of our pour verifications. We're still doing the 2D drawing, but this just gives us another way to kind of look at all of this data. So we've got another walkthrough here, kind of going through a space where we can move through really easily. We can see photos, we can incorporate all of this data. So I think as we start to go through some other projects we're working on, you'll see kind of some of the features of these projects, or programs, so we can really easily turn things on and off. We can really see what we need in order to provide value to our projects. So we're going to take a look at some case studies to look at how we're using projects kind of throughout the course of construction. So we're going to look at some proposal and marketing, some pre-construction constructability, coordination, and then really how we're using it in construction. So I'm going to go ahead while Matt gets this presentation pulled back up.
Oh, is that not showing anymore?
No.
I've got another.
Okay.
Oh, and it's like closed caption too.
You guys are able to see it once again, correct?
Yeah, there we go.
Yes.
So we're
Great.
also learning about Microsoft Teams today too, a little bit. But I'm going to go ahead and let Matt talk about some work they're doing in the proposal phase of a project.
Thanks, Laura. Yeah, so this is just one case study that we have for a project proposal in working with our marketing division. So what you see here on the PowerPoint is 4 slides out of, I believe it was 15, that are showing some phased logistics plans that were marked up within Bluebeam. So what you see here is not only information concerning site logistics of this potential site, which is the Carolina Yards project in Cary, but also mixing in with our pre-construction schedule so that we can tie in some milestone dates and make sure that we're adhering to a strict schedule. And so with a combination of this phased logistics plan and a couple of other things, you get here a 4D schedule that was created. So what we have going on here is the Bluebeam logistics plans brought in some data from Google Earth and also drone shots that were mixed together. We have some massing of the existing buildings that was done in SketchUp, and those buildings are going to be staying there. And then what you have here is layers coming up from the architect's actual Revit models. And so not only is this a very visually interesting approach to give to an owner and a designer when you are bidding, but it's also information rich. And so we found that this approach to putting in proposals has actually been very, very successful for us.
So, taking a look just with Matt before we get the work. Now, once we're awarded work, our VDC team is working with pre-construction in a couple different areas, which I'm going to highlight now with some work we're doing with Wake County Public Schools here in our Raleigh office. So as Harry mentioned in the intro, we're looking at a new high school here, and the designer has actually shared their BIM 360 hub with us. So what that means, you can see here, I can flip to their hub, I can open their model when they publish it within this 360 viewer, and I can have that conversation early on with the design team about how we intend to use the model so that we can really set that level of expectation early on. We're also using Assemble with our pre-construction team to easily pull out quantities from the model. Our VDC team does some model conditioning, kind of looking at the model, seeing what's in there, making sure we can get what we need and where we might need to fill in gaps. And then if we look at this next slide, we can actually pull out really easily to look at specific elements. So this can be helpful to do not just a numbers check, but really a visual check to see, okay, if we're counting out interior walls, this is what we're looking at. We also have the ability to really easily compare. So here we're comparing a 60% CD model to a 100% CD model. So once again, when it comes to doing a visual check, we can see what's been added or removed and what quantities have changed. We can pull this information out to Excel for further editing. And in this case, again, it's a comparison. Comparing is a really good use of this tool. So we're not looking at the specific number, but really how they relate between different stages of design. So we want to take kind of a little step back and talk about how we are using a model throughout, all these phases that we're talking about. I know Cassie kind of touched on this a little bit when she was talking about the CM Bim courses, but this is kind of the progression of a model within our department and how we can help you all as well. So we start with a model that we're either getting from a designer, anyone in the design team, subcontractors. We are sometimes doing supplemental modeling ourselves to kind of fill in some gaps. We then take all those and we merge in glue. So if any of you have been sitting in a coordination meeting and hear someone say, I glued the model, that means that trade uploaded their most recent model in this glue platform, which is an Autodesk product. We then can open that model from glue directly in Navisworks, and that's where we're running our clash detection that you all are familiar with. The advantage too is that the subs can open it directly from glue in Navisworks, so they can do their own coordination with updated models from other trade partners before we get together and all meet. We can then take the clashes in Navis and the model and export that out to Revisto. So here's where we can do some more visual checking of the model and issue tracking. So another Wake County Public School project here is this middle school where we helped pre-con with constructability review at a few different stages of design. Here in Navisworks, because this was early on, we were able to kind of pull out these ideas, provide a report to the design team. The advantage here was we were able to identify where some roof drain later piping was coming out through foundation, so the designer was actually able to make changes to the drawings before the 100% set came out. The way we were tracking all these issues, we were then able to kind of track, if we look at this next slide here, we were able to track those as we moved into coordination. So this kind of transitions into what we're going to talk about next. Like we said before, here's where we're in the Revisto platform. We've got the foundation plan overlaid, and we can really see how plumbing and electrical is working underground and kind of comes up through the slab. Because we did that constructability review early on in the model, we then pulled it out to Revisto, and as we are working through model coordination, we are actually going back and kind of checking those issues. So here was a duct that in the designer model was running through the steel beam, so we just want to confirm, because we knew that was tight, that we picked it up during the coordination process. We can pull out reports really easily from Revisto as well. These are some examples during our just standard coordination meetings, but we can produce a report without having to write all this out. We're actually taking notes within the platform as we go through coordination, so we can provide a record of our meetings and we can track it really easily. We can also communicate with the design team really easily. We can just tag items specifically to be handled by the designer, give them this report. It gives them a really nice screenshot and a description of what we've talked about in the meeting. So we can use all these tools, like I said, as we move from pre-construction and then move into coordination. And so Matt, Zach, and Todd are going to talk about how we're really some updates to our model coordination on a few projects. So go for it, Matt.
Thank you. Yeah, so this is just a case study of one model or one project that we currently have going on. This is the One Walker building over at the Academy Park site in Cary. And this project is currently just finishing up its underground coordination at the moment. But I thought it was important to look at this case study in particular because one of the big items that we had to contend with was all of our underground electrical and plumbing, piping, and conduits going through aggregate piers on this project. And so that took a lot of coordination and a lot of meetings in order to make sure that we were able to effectively route all of our conduit and piping around those piers. And I think that without the approach of doing this coordination early, the job site team would have had much more of a headache if they had just tried to do it in the field. And so that's just one example of where VDC early and often has really paid off in dividends. Next, we have
right.
City View 2 apartments.
Yep, thanks, Matt. I'm going to talk a little bit about the City View 2 apartments in Virginia Beach. One aspect that makes City View 2 unique in terms of VD&C is that we did almost all the modeling and coordination in-house, starting basically from scratch. None of the designers worked in 3D for this project, and the fire protection sub was the only trade that provided a 3D model of their work. We started off modeling kind of as much as possible right as the site clearing and ENS were starting. This was probably a little bit overambitious, but we caught a couple major conflicts between the disciplines early on. Some of the examples shown here on the screen, we had a number of cases where the proposed depths for the perimeter pile caps and grade beams were actually above the existing sidewalks and some of the proposed grades near property lines and some of the other critical elevations that couldn't really be changed. We also had a number of interior pile caps, as shown in the photo on the right, that were too shallow for plumbing stacks to turn horizontal below the slab. So we were able to identify all of these pile cap and grade beam issues well ahead of piles starting get approval to get those lowered and, you know, make everything work. There were also a number of instances, as shown in the photo on the bottom, where we had the structural slab edge plan didn't show some cantilevered slab edges that were needed to pick up some of the more architectural elements like canopies and eyebrows. So we were able to get those coordinated ahead, well ahead of that concrete work starting. Next slide. There were also a number of conflicts with elevations for the stormwater between the plumbing and the civil plans. For the most part, the plumbing plan showed all the inverts of the stormwater leaving the building about 2 feet deeper than civil. And this is a very shallow site. The site's only about 9.5 feet above sea level. So the underground detention system and the storm system had to be, you know, very shallow. The longest stormwater main picks up about half of the building's rain leaders, and it was about a 250-foot run with almost 2.5 feet of fall within the building footprint. The original design didn't fit vertically between the underside of the garage slab and the inlet to the underground detention system. To correct this, we rerouted multiple storm mains to either shorten the run or allow for a shallower slope in order to stay below the slab on grade. And we were also able to lower a few of the perimeter grade beams where there were conflicts between the storm line, which basically couldn't move, and the beam elevations. Once construction was well underway, we kind of started only modeling what was directly needed for coordination. Because of the sequencing of this job, as you can see in the photo on the top left, we essentially had one corner of the building topped out while the other corner still had foundations and underground MEP going in. By not modeling everything, there was always some risk of missing some issues with adjacent areas and systems that weren't modeled, but there wasn't really enough time to model everything and still stay far enough ahead on coordination. One way we accounted for this was by leaving in tolerances and windows for field coordination where it was too difficult to coordinate virtually in the available time frame. So for example, we had a number of issues with above ceiling coordination in the corridors where we were able to show the design team that the duct as designed didn't fit above the ceiling. There wasn't enough ceiling space. So rather than modeling individual plumbing and sprinkler branch lines, we were able to just coordinate a 2-inch window below the duct where all these lines could cross while still ensuring there were no major conflicts. Basically had to lower the ceiling to allow for that. Another aspect that we kind of handled maybe a little bit differently, the second and third floor sleeve penetrations were done almost entirely in 2D within the 3D Revit model, which was really just used for context to identify any conflicts, such as sleeves falling within the column drop panels on the underside of that level. All of the apartment MEP sleeves were modeled and coordinated in 2D with input from the trades, and then sent to the subs for their review and kind of final verification before being sent to the design team for final approval. Once approved, the 2D shop drawings were finalized by us in-house and then issued to the field for their use to lay out the sleeves before rebar went in. Based on the experience of working, primarily off of 2D info with no models from designers, it's a good idea, if ever in this same situation, to prioritize modeling and coordination based on key components like any early critical path items or any pinch points within the building where you have a lot of systems that have to fit. It's pretty much impossible to achieve full coordination without being handed a starting point 3D model, but it's better to focus efforts where coordination is needed most. And now I'll turn it over to Todd to talk about the AC Marriott Greenwood.
Thanks, Zach. So on AC Marriott, we actually did a full collaboration model. Our subcontractors were on board and we held weekly meetings. I'm going to focus on one key area where this really helped us. What we're looking at is kind of a before and after, or a proposed and accepted design. Initially, we had a utility yard. It's in front of our main mechanical room. We have a transformer. And what we had to do was get a water meter, water vault, and then 2 backflow preventers into this area. And we were able to use our modeling to illustrate that, you know, we understand that the designer said put it here, but we don't have that clearance. So what you're seeing on the upper left side of the presentation is where they were showing the water meter and the RPZs. The city of Raleigh said we couldn't go more than 50 feet before putting in the backflow preventer. On the bottom right-hand corner, if you look at the model, we are able to add things like our clearance zones required. So we have a transformer. The power company says you must maintain 10-foot clear in front of this transformer. So it was a reminder, a visual reminder, that we couldn't locate things. So as we started moving things around, we held team meetings and came up with a proposed solution. Go to the next slide. So what we have on the first graphic there is kind of a, here's what we're trying to do, and there's just so much pipe work going in the ground, we had many difficulties lining it up. The other problem was the civil engineer had designed the water pipes to actually go through their drive aisle. With our work in the model, we were able to show them that, hey, if we locate it here, we can actually run our water pipes around the back side of the electrical room, making for a much simpler install. And with this additional information, we were able to convince the city of Raleigh that there wasn't sufficient room to install all of the utilities in this location. And with all of this data in front of them, they were able to go ahead and approve an exception for us. And we were actually able to install our backflow preventer for the sprinkler system within the building, well beyond the 50-foot limitation they would normally impose. So this is an example of how we've taken data and can take it back to other users to help them see what we're proposing.
Thanks, Todd. So now we're going to kind of blur the line between what we typically think of in model coordination, what you all think of with BIM coordination, and how we're kind of continuing use throughout construction with the model. I'm going to briefly kind of talk here about 301 Hillsborough, which I know you probably saw in those intro videos to Revisto that we were talking about. So here we have trades updating the model once we issue coordination drawings. So whereas before drawings might just have been, or drawings were edited, now we're doing this all in a model environment. It's been, I think, really beneficial to this project to have the superintendent team and the project management team involved in all of our BIM coordination meetings. That way, myself as a VDC coordinator, I have a better idea of what's going on out on site, and we can communicate a little bit better to make sure that we're hitting all those deadlines. Same thing, Revisto has been really good in here for tracking on these issues as we are going farther than we normally would. Kyle talked earlier about Donley's on the Peace Project, how they then got one of their staff to for drone flights. So what we did here at 301 is we actually were able to use that drone data from Donley's in order to do our poor kind of overlay drawings. So it was just a way to share this information and really have a good, build on that relationship, but also save us some time in the end. So I'm going to turn it over to Kyle now to talk about the Rigsby Apartments and a little bit more about open space.
Sure, thanks, Laura. So I just want to start with this image because I think it kind of encapsulates everything that we've talked about previously. So this is on the Rigsby project. I kind of created my own little dashboard here of various links. So just starting out on the left, I mean, you could see we're using BIM 360 on the project. We have our model coordination. Then the right-hand side, it's, you know, all this photo documentation now we have in our job sites. You know, we have the handheld cameras, we have the job site cameras. We have even take the drone up. We can take some 360 photos from the aerial with the drones. And then there in the middle is, you know, us producing our drawings, taking that drone data and, you know, kind of creating these overlays that we can do. So we're kind of bringing a lot of this technology to our projects. And with the next slide, I'm going to kind of touch on one of the items here that we, you know, used our technology to help the project with. So in the top left corner, I forget where, but out by the road, there was some utility connections that we needed help coordinating. We had 2 grease traps and then a big sand filter there in blue. On the top right, you can see the design called for these temporary soil nails to go underneath the road in order to allow us to excavate and install those grease traps. And during project, there came a number of conversations about them being temporary, who would have to remove them down the road, who would have to pay for them, and it became, quite the headache that we were basically wanting to evaluate if we could do away with them if needed. So on the bottom is where we're using our authoring software to put some of these sketches together, analyze it, and see if we could just get that normal slope there, so we can install those things without any of those temporary soil nails. So this next video is going to kind of, I think, encapsulate some of this, like the combined work here with Revisto. So we're able to overlay our utility drawings. Then zooming down in here, this is a drawing I put together myself, noting some invert heights. We're just looking at what the depths of these grease traps are actually going to be. There's, pulling that setback line from the face of curb, making sure that we're above there. And then this is bringing in that drone data so I can actually verify, hey, this face of curb we're shown in the model, is this actually face of curb or what am I looking at? So that's just kind of a back check there. And then this, I think it's just going to fly through. I just think it looks kind of cool, everything all together. And really, it's bringing all these things together to look at it in a combined environment. And I guess the summary of this story is that we were able to prove, yeah, we can install this without those temporary soil nails. So we're able to, eliminate that from the project, and I'm sure it got rid of quite a bit of headaches and cost along with it as well. So now I'm just going to run through a few images here, kind of describing the construction of the project and showing off open space. So here we have, bringing up that model side-by-side comparison. So there's that sand filter that got installed, and there's a nice electrical room you could see on the right, all in that magenta color right there. So it was coordinating, those feeder lines, and plumbing piping was quite fun. Next slide, we're now working up into the parking deck. And to me, this is, a good visualization of just, hey, construction to finished project there. And we are coordinating a number of overhead services, supporting that podium above. So now jumping ahead to the podium, for those that maybe haven't seen this before, I thought it'd be good to show a little video here. Matt, I don't know if you can click the video, it may just not play automatically. But this is basically how we're performing these overlays. Yeah, here we go. So we can, we have a set of drawings that we've established where all those sleeves are. We can bring in this drone data behind it. And typically my workflow is to bring this in the Bluebeam and then we overlay a number of drawings on there. So not only do we have our sleeve drawings, but we can do, the PT shop drawings, architectural. The one you just saw there before was like our embeds, like our embed shop drawings. So, we overlay all these in Bluebeam, and it's kind of like pretty manual process. I just go ahead and we look to see where things are and then note it and pass it along to our field team. So this has been I think it's been very successful in all our projects, and every time people seem to really enjoy the value that it brings. So we're continuing it on this project as well. Matt, you can go ahead and flip to the next slide. And then, so this is kind of like building upon that PT slab coordination. Now, I think this is the first project where we've actually been doing deck walks with open space. So on the top right, you can see that green line is the path that our field personnel walked out there with the camera. So you can see we're getting, coverage across the entire deck. And you could, you can imagine in your head how many photos that would be to cover all this area. So now this next slide, not only can we do this once, but we can walk the deck multiple times. So here we can kind of do a comparison to a previous date. And then we even have one more going back to the formwork before anything was on there. So to me, I like these images because it really shows how much is involved in these PT decks. And then in here, you can even bring this up in the meeting and say, hey, at this point, you got to have your stuff in, or you can see some embeds that are buried over top of PT cables and rebar. I can see a lot of value to, time stamping this. So Matt, you can go ahead one. Yeah, this is just that bare form work, which you could see all the work that actually happens in a pretty short period of time. And next slide. So now this is kind of wrapping up here open space, and it's really highlighting, I think, where the biggest benefit is that I've heard, like, you know, the return on investment is once everything's all, you know, covered up, set and done, the ability to go back in time and pull up what it looked like previously. So here we're looking at, you know, the PT deck, and we could see everything that was embedded in this slab here. Going ahead to the next slide, this is another project on the Smoky Hollow development. And some feedback I got from them, the real benefits they found was being able to do this, you know, with our framing walls, going back and looking at rough-ins. And one thing they told me is there were, I don't know how many places this occurred, but a number of outlets actually got covered up by the drywall sub that came in. So they were able to quickly pull up open space, and they could, you know, look at a room where all these outlets would be, so they could go back and cut them back out, which saved them quite a bit of time. And just to wrap up, I guess everything here is, as Harry mentioned before, we do have like a corporate-wide agreement with Open Space. So one thing that this has allowed us as well is we kind of have a seat at the table, so to speak, with their product development team. So I've been in talks with them quite a bit on meetings, and the really great thing about that is we can the direction of their product, and we give them feedback on, hey, I'd like to see this, or we're having an issue with this over here, and they're pretty responsive in that. So the more, you know, we start to use it, and people on this call are using it, if you have, you know, comments or feedback, you know, feel free to, you know, push that through me, and then I'll transfer this onto Open Space. And the one thing I was going to say over on the right that they're really making advancements with, a little kind of peek into the future, is they're starting to overlay some AI technology on all these photos. So on the right, you can see you can like search all your photos for a particular object. They're doing some progress tracking where you can monitor like how much walls are being framed. So there's a lot of really cool stuff on top of everything I showed that they're going to continue to develop. And yeah, we're at the beginning of it, and we're helping them create their product alongside us using it. So it's great. And with that, I mean, Harry, I don't know if you want to say anything else, or we just open it up.
No, I think great job, everybody. Thanks for presenting what we do and how we do it. And so questions, if you want to maybe put them in the chat, that might be the best way to do it. And please ask lots of questions, and we will give you some answers. And if you want to just ask a question, you know, go ahead and unmute yourself. That works too. I think we must have covered it so well that it's left everybody speechless.
Looks like it.
Yeah, it's just an incredible job, Harry, and Kyle and Todd and Cassie and Laura.
So, Harry,
thanks.
I have a comment, not a question, but just a addition to how this software has helped in pre-con. One thing that when we get hard copies and we're doing just a budget and we get electronic copies of the drawings, we may not always have all the building elevations or secondary elevations or cut through to the building. So this software, the Revisio and the Assemble, has allowed us to explore the architect's model to see, hey, what's the skin material on this elevation that's not provided. So it's helped us in our budgeting, filling in the missing pieces to the puzzle. So we've used it to help with actual budgets.
Thanks, Brenda.
I think, you know, we talked about how we're using all this different data, and I think that's really important what Brenda just said. Like, we want other people with Clancy and Phase to be able to get into these models and see things they might not see on the drawings, and just get a good feel for the project even before we get into the coordination step.
All right, well, for attending, and as I pointed out, you know, we do have corporate resources in Raleigh to help you out. Part of the idea of the CM Bim classes was just to give every office an understanding of what's involved, how you put a team together. But we are here to provide the support and the the heavy lifting on some of these jobs in terms of modeling and running coordination meetings and things like that. So please feel free to call on us to help get some of this implemented in your division if you feel like you need something that we've got. So I will close it there. Thanks again for everybody.
Good job, guys. Thank you.
Thank you.
Very
All
helpful.
right.
Thank you.
Thank you.